Good morning, everyone. It's a great pleasure to be here today. And my name is Yu Chu. Today I'm very excited to present my project, which is Sharpshooter. An intelligent mobile application to improve users' shooting motion and compare them with NBA players using machine learning and large language model. Okay, now, yeah, here is the content. Like the first part is introduction, and the second one is app overview, and the third one is system architecture, and the fourth one is AI model, and the fifth one is experimental results, and the last one is conclusion. Okay, let's get into the first part, introduction, about who I am and why I do this. I'm a senior student majoring in computer science at Nanchang University in China. Before we go further, allow me to say a few words about my university. Nanchang University, or NCU, is one of China's key double first class and Project 211 universities. It's located in Nanchang, Jiangxi Province, and is jointly supported by the Ministry of Education and the Jiangxi Provincial Government. The university has a strong focus on innovation, engineering, and computer science. I've had the privilege of studying here for 4 years, and the resources, mentors, and research environment have been instrumental in shaping this project. Before we get into the technical part, let me briefly share why I decided to work on this topic. Basketball has always been one of the most popular sports in the world. According to FIBA, the International Basketball Federation, there are about 6.1 million people aged 6 to 54 who play basketball at least twice a month. That's an enormous community of people who share the same passion for the sport. However, not everyone has access to systematic or professional basketball training, especially in developing countries. Only 1% to 3% of players ever receive formal coaching. When I first learned about this, I realized how many players are left to practice on their own, often without guidance and with limited understanding of what makes a good shooting form. Most enthusiasts simply imitate professional players but without feedback. It's hard to tell if they are doing it correctly, so I began to wonder, what if we could use AI to bring professional level training and feedback to everyone right through their phones? And that's how Sharpshooter was born, an AI-assisted mobile app that helps users improve their shooting posture without the need for professional coaches or expensive motion capture equipment. It's designed to be accessible and easy to use and fast enough to give real-time results. Now let's move on to what Sharpshooter actually does. The goal of this application is very simple: to help basketball players improve their shooting posture through AI-based motion analysis. Users can record or upload a short video of their shot. The app processes the video, identifies body movements, analyzes posture, and provides an evaluation almost instantly. The user's experience is designed to be intuitive. When you open the app, you can see three main options: upload videos, record shot, and view results. Once a video is uploaded, the system automatically detects your shooting motion, extracts key information about your body position, and then gives feedback in both visual and textual form. For example, it might highlight that your elbows isn't fully extended or that your wrist release angle is slightly off. This makes Sharpshooter a virtual coach that provides immediate and objective feedback, something that's traditionally available only to professional players or those who can afford private trainers. Now let's take a closer look at the system architecture and how everything works behind the scenes. The system is composed of three main layers: the front end, the back end, the cloud service, and the database. Each part has a specific role but works seamlessly with the others to create a smooth and reliable user experience. First, the front end, which is the part users interact with, was developed using Flutter in Android Studio. Flutter is a cross-platform UI framework developed by Google, which allows the same code base to be deployed on both Android and iOS devices. I choose Flutter because it provides a what you say is what you get interface, meaning that the design and performance are consistent across devices. From a development perspective, Flutter offers a rich widget library and supports reactive programming, which allows quick development of features like video uploading, data visualization, and result display. For the users, this means they can see their shooting motion breakdown, the AI's analysis, and their feedback in real time. The app feels responsive and professional, which is important for maintaining users' engagement. Moving to the backend, this is where the real computation and AI analysis happen. I used Flask, a lightweight Python vibe framework, and built everything inside PyCharm, which is professional IDE for Python development. Flask is ideal for projects like this because it's simple to set up but highly flexible and scalable. It handles requests from the front end, such as receiving uploaded videos, passing them to the AI model for analysis, and returning the processed results in JSON format. PyCharm made backend development more efficient through its debugging tools, dependency management, and code organization features. Together, Flask and PyCharm provided a stable environment for integrating machine learning components with web service. For deployment, I rely on Amazon Web Service, AWS, for hosting. AWS provides elastic computing resources, which means the system can automatically handle multiple requests without slowing down. This ensures that users from different locations can access the service smoothly. Meanwhile, Firestore serves as a database to store users' data, models' outputs, and historical analysis results. It's a scalable, cloud-based NoSQL database that ensures data persistence and security. With these technologies combined, the sharpshooter system is capable for real-time response and stable operation under heavy loads. Now let's move on to the AI model, the heart of this entire system. The main task of AI components to analyze a player's shooting motion and classify whether the posture is good or bad. To achieve this, I need a way to extract reliable motion features from videos. For that, I used MediaPipe, a framework developed by Google for real-time human pose estimation. MediaPipe can detect 33 body key points, including the wrists, elbows, shoulders, hips, and knees. For this project, I focused mainly on the upper body, since the arms, shoulders, and wrists play the most crucial role in shooting. Here's how it works. When a player uploads a video, MediaPipe processes every frame and outputs the 3D coordinates of these 33 landmarks. This data captures the spatial and temporal motion of the player's shot. Once these key points are captured, the next step is temporal feature